But I see here one more topic is there in the thermodynamics, that is about bond dissociation energy and heat of atomization. Here bond dissociation energy is given in this way: BDE or BE. The energy required, right? The energy required to dissociate, the energy required to dissociate one mole bond into gaseous atom is called bond dissociation energy. Then heat of atomization is also one of the concepts to understand here. Heat change during the breaking of one mole of compound into constituent atom. It should be constituent atoms are there, that to be in the gaseous phase. Then it is called as a delta HA, heat of atomization. Example you can see here. I have given the example methane, right? It is the one mole of the compound and it will be converted into its constituent atom like carbon gas, hydrogen gas. So it is a delta HA we can get for this one. Ammonia, constituent atom, atom, hydrogen atom in the form of gas. Hydrogen gas, when it is ionized, so it cannot be given here as a heat of atomization. But hydrogen in the form of a gas given as a two atom of hydrogen gas, we can calculate the heat of atomization. To understand this concept, now we'll see the diatomic molecule and polyatomic molecule. What is a diatomic molecule and what is a polyatomic molecule? For example, I am having for diatomic molecule, bond energy must be equal to heat of atomization, right? And for polyatomic molecule, more than two will be there, that is a polyatomic molecule. You know, bond energy must be equal to heat of atomization delta HA by by number of bonds. Let us go with the example here. Instead of writing in this way, we'll go with the example now. See example now. I will go with one example here. It is a H2 in the form of gas. It will be converted as a 2 hydrogen atom in the form of gas. Second example now, Cl2 diatomic molecule converted as a 2Cl in the form of gas. Third example, H2 in the form of gas, diatomic. It is also converting in the form of a what? It is also converting in the form of what? We can say 2H in the form of gas. In all these examples, if I'll ask you, what is a bond energy of H2 molecule? So you should say, whatever the heat of atomization is there, that is the bond energy. In this case also bond energy equal to delta HA. In this one also bond energy equal to delta HA, right? We got it here. But now at the same time, if we are calculating in this way, instead of this one, if we are calculating in this way, 1 second. Okay, I am having the example of H2 gas, and now instead of breaking up into atom, I have ionized it in the form of gas. But in this case, we cannot calculate bond energy, even we cannot calculate heat of atomization. Got the point? Suppose one of the compound I wrote is the H2O, and when it is decomposed as a H plus and OH minus, for this ionic form, we cannot calculate bond energy, and even we cannot calculate its delta H heat of atomization. Now other example we'll take for polyatomic molecules. Now for polyatomic molecules, I told you bond energy must be equal to heat of atomization by number of bonds. Example we'll see now. CH4. This is the example is there. Uh, in this example of CH4, we can write in this way: hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. But when we are going to break, I will get carbon as a gas and 4 hydrogen in the form of gas, right? Actually, what they give, no, in this case, they have mentioned heat of atomization is 1665 kg per mole. That value they give, and they are asking to get the bond energy of carbon to hydrogen, asking to calculate. See with a simple formula. It is a polyatomic, means atom more than 2, 4 hydrogen, 1 carbon. So our formula is that bond energy equal to heat of atomization by number of bonds. What is the heat of atomization? 1665. And number of bond is how many? 4. CH one bond, CH one bond, 3, 4. And by solving, you'll get the answer is a bond energy of carbon to hydrogen. But one more example I'll tell you. Uh, After CH4, we'll go with the example of one example as a ammonia. Suppose this is a ammonia, it is in the gaseous state. I'll get the nitrogen atom in the form of gas and 3 hydrogen atom in the form of gas. Let us say heat of atomization they give as X, and they're asking what is the bond energy of nitrogen to hydrogen. So, but how to calculate? It is a delta HA by number of bond. But the number of bond, for ammonia, it is a NH1, NH2, NH3. So it is a X by 3 is a bond energy of a NH bond in ammonia. But how to get the heat of reactions? Heat of reactions. So one more formula: heat of reaction is equal to summation of bond energy of, remember, reactant minus summation of bond energy of product. But this reactant minus product is the only formula we have to use to calculate the heat of reaction when the bond energies are given. I'll show you one example, one numerical for this one. See, this is a numerical was there. Just a minute. Bond dissociation enthalpy of bond dissociation enthalpy of H2Cl2 and HCl are 104, 58 and 103 kilocalorie per mole. Calculate enthalpy of formation of HCl. See here, bond dissociation energy they give. H2 converted into 2H in the form of gas, Cl2 converted as a 2Cl in the form of gas, HCl converted in the form of hydrogen gas and chlorine gas. For all these one value given as a 104, 58, 103 kilocalorie. Now they are asking enthalpy of formation of HCl. But a formation of HCl means first you write the reaction where you are able to show formation of HCl. You know how? H2 plus Cl2 and it gives HCl. But a formation of HCl means it is a 1 mole. It should be 1 mole. For balancing, it is a 1 by 2. It is a 1 by 2. And in the form of gas, we did here. But whenever you want to write the delta H of the reaction, you know how to write. Delta H is equal to summation of, see here, delta H of the reaction equal to summation of bond energy of reactant minus summation of bond energy of product. What is the reactant we are having? Reactant is here hydrogen and chlorine. But what is the reactant we are having? We are having the bond energy of H2 plus bond energy of chlorine minus bond energy of HCl. But beta H2 is how many mole? Half mole is given. So 1 by 2 into 104. And chlorine also half mole. 1 by 2 into 58. Minus it is a 1 mole. 103. You solve it, you are able to get the delta H heat of reaction value. It is equal to somewhere as a minus 22 kilocalorie per mole is a delta H of the reaction, is heat of the reactions. Instead of the bond energy is given, we are able to calculate the heat of the reactions. One more example I will show you, because this kind of the numericals they will ask in the exam. The bond energy of HH and ClCl are given as a 430 kJ per mole and 240 kJ per mole respectively, and heat of formation of HCl is given here as a minus of 90 kJ per mole. They're asking calculate bond energy of HCl. See beta, bond energy of HH and ClCl gave, HCl gave bond energy of HCl they are asking. But a very simple way, same way, half H2, half Cl2, 1 HCl. Heat of formation or reaction equal to summation of bond energy of H2 plus Cl2, right, minus summation of bond energy of HCl product. But a heat of formation value is given as a minus of 90. H2 until it become a 1 by 2 into H2 430 plus 1 by 2 Cl2 240 minus what we required, bond energy of HCl, right? So I'll write here as a bond energy of HCl. You solve it, we are able to get bond energy of HCl is equal to 425 kJ per mole, right? Now sometimes the question they are giving in this way also. From the following bond energies, see question how it will be. From the following bond energies, bond energy of HH, bond energy of carbon to hydrogen, bond energy of CC, bond energy of carbon double bond carbon. See this value they give 103. Second is 99. Third is 80. Fourth one is 145 kilocalorie per mole they give. Now they're asking find the enthalpy of reaction. Find enthalpy of reaction C2H4 means it can be written like that plus HH, and it will be converted into ethane. C2H6 is the ethane. See what these kind of the reactions can be done in this way. The delta H of the reactions heat of the reaction, that is equal to, see here, summation of bond energy of reactant C2H4 plus H2 minus summation of bond energy of C2H. This is the formula we have to use. Reactant minus product, and reactant is, this is there. One second, you should know the values also now. Now we are able to see it. Here, delta H of the reaction equal to C2H4 me you can count here. How many carbon, double bond carbon is there? Only one, and its value is 145 plus how many CH is there? 1, 2, 3, 4. What is the bond energy of CH? 99. This is a complete part for only C2H4 over plus hydrogen HH, and HH bond energy 103, right? Minus C2H6. How many CH bond are there? 1, 2, 3, 4, 5, 6, and CH bond energy 99 plus how many C single bond C? Only one, bond energy 80. You can solve it. You will get heat of reaction is 70 kilocalorie per mole. 70 kilocalorie per mole. So these are the complete part of the, we can say, heat of reaction was completed here.